Okay, so we begin by asking, what must the definition of number be? It must be objective. If it's objective, it is a fundamental truth, and it's a firm base on which we can stand to make our argument. Now, because definitions are objective, it does not matter if mathematicians are the ultimate arbiters, because whether they be mathematicians or philosophers, they are independent of what is actually a number. And this is a very important concept, the concept of objectivity throughout our proof. Now, Frege successfully and validly derived Peano's axioms, and this is known as Frege's theorem, which is also now used to prove Peano's axioms. And because Peano's axioms are objective, because they work in all cases in any base, we use them as the basis of our argument. So what are Peano's axioms? Well, the first one is that 0 is a number. And if n is a number, then the successor of n is also a number. 0 is not the successor of a number. Two numbers of which the successors are equal are themselves equal. And if a set S of numbers contains 0 and also the successor of every number in S, then every number is in S. Therefore, we ask one final question. If infinity is a number, what number then precedes infinity? Perhaps it's infinity minus 1, like it would be in any other set. But this presents a problem. In your previous video, you put forth that if n is an element of the reals, then infinity plus or minus n is infinity. So infinity minus 1 is infinity. Similarly, infinity plus 1 is infinity. But because infinity and 5 are both apparently numbers, we can substitute them and expect something of similar form when we use the number 5. So 5 minus 1 is 4, 5 plus 1 is 6, and we find that 4 and 6 are not equal. This contradicts the fourth of Peano's axioms. Therefore, infinity cannot be a number.